Hi, welcome to CS517A Multilevel Queue Scheduling. A multilevel queue schedule algorithm partitions the ready queue into several separate queues. For you to understand it better, let's have an example. A common division is foreground and background processes. The foreground processes, from the name itself, is running in the foreground with direct interaction with the user. So these processes needs to be quick and interactive. The background processes are running in the background and may not be in direct interaction with the user. So these processes may not have to be as fast as the foreground processes. So depending on the process, they have different response times requirements. As I said, foreground processes needs to be quick and the background processes don't need to be as fast as the foreground. Therefore, they have different scheduling needs. In addition, foreground processes may have priority over background processes. So as the foreground processes is in constant interaction with the user, if these processes ends up waiting for a long time in the ready queue, waiting to get the CPU, what will happen is that the response time of these processes will become long and hence it is going to be a slow experience for the user. So we have to make sure that the priority of the foreground processes is higher than that of the background processes so that the user can have a quick interaction with the system. So you see, processes has different scheduling needs, and this is now where multi-level queue scheduling comes into picture. It partitions the ready queue into several separate queues. In multi-level queue, the processes are permanently assigned to one queue, and each queue has its own scheduling algorithm. For example, the foreground queue might be scheduled by a round-robin algorithm, while the background queue might be scheduled by a first-come, first-served algorithm. To explain it further, I'll give you another example. So here, we have three sample processes: system processes, interactive processes, and batch processes. As mentioned in the previous slide, the processes are permanently assigned to one queue. In the picture shown here, system processes is assigned to Q1, interactive processes is assigned to Q2, and batch processes to Q3. I also mentioned that each queue has its own scheduling algorithm. So for example, Q1 might use round-robin algorithm, Q2 might use shortest job first algorithm, and Q3 can use first come first serve to schedule their processes. Note that these processes, system, interactive, and batch, are also following its own scheduling algorithm, Q1 having the highest priority and the queues following will have lesser priority. So in this picture, it will do the system processes first, followed by interactive processes and then the batch processes. It is not possible to interchange the processes once it has been partitioned in a multi-level queue scheduling. So that's one of the disadvantages of this type of scheduling. It is inflexible in nature. You cannot move higher queue to lower queue and vice versa. Second, some processes may starve for CPU if some higher priority queues are never becoming empty. Now let us explain starvation in multi-level queue. For example, Q1 has three processes, the P1, P2, and P3. These processes has to be executed first by the CPU before it proceeds to the interactive processes, wherein here there are two. After executing all processes in Q2, it will then proceed to Q3. That's how the algorithm of multi-level queue works. It executes from high priority to low priority. Now, assuming all system processes and interactive processes are already executed by the CPU. The next in ready queue are the batch processes. But then, for example, one process entered in the system processes. What multi-level queue will do is it will execute that first, where in this example it is P9, before it proceeds to the lower queue. And when another process entered in the interactive processes, which is the P10 here, in this example, again, it will still execute that first before going down to the lower priority. So here is when starvation comes into picture. If the higher priority processes are never becoming empty, like in our example, there's always filling in the system or interactive processes, the batch processes will never get to be executed. So just a recap, processes has different response time requirements and different scheduling needs. That is why a multi-level queue schedule algorithm partitions the ready queue into several separate permanent queues. Permanent because you cannot move highest priority queue to lowest priority queue and vice versa. And then each queue has its own scheduling algorithm. Wherein, as I mentioned a while back as an examples, are round robin, shortest job first, and first come, first serve scheduling algorithms. And then, thanks to these references that I found in the internet. So that's it for now. Thanks for watching.